My name's Will.
My name's Anna.
My name's Keith.
My name's Connie.
My name is Thomas.
Throughout this project, we've been working on a sustainable engineering solution that addresses pharmaceutical contamination in hospitals.
Over the past 3 months, we've went from ideation to prototyping and eventually to refining a solar filtration system to overall help reduce pharmaceutical waste in hospitals.
Hospital waste often contains harmful chemicals which need to be disposed of to the landfill or through incineration. This leads to the increase of greenhouse gases and eventually to global pollution. Our team's goal was to decrease the amount of impact that hospital waste has on the environment. We did this through designing a solution which could clean supplies to be recycled while renewing water. We decided to use solar panels to additionally lower our carbon footprint. As a team, we also had to seriously consider the size and availability for hospital facilities that have limited room and budget. To complete this project, we had design specifications that reference upkeep and cost to make this more accessible to hospitals or clinics. Ultimately, by designing this filtration solution that sustainably uses energy to clean waste, we can decrease hospitals' carbon footprint and spending while also introducing water back into circulation.
Our final design is a solar-powered distillation system that can be implemented in a hospital drainage system. The design consists of a stainless steel heating chamber which has a tube connecting it to the cooler area. By boiling the contaminated water with the help of the energy from the solar panel, the ultimate goal is to transport the steam to a cooled collection area to condense back into water with the hope that there are no contaminants remaining. The perks of this design is that the solar-powered panel would allow for it to be sustainable and ultimately eliminate the need for electricity.
Our first prototype was virtual, focused mainly on selecting the right materials and a basic design to start the iteration process. After comparing copper, aluminum, and stainless steel, we chose stainless steel because it resists corrosion, has reasonable thermal properties, and can be sanitized between uses. It also has a reasonable cost. Our second prototype was our first physical build, using a large steel pot, aluminum foil seals, and steel pipes. We tested how efficient the boiling of the contaminated water was. We also tested the efficiency of the steam that could travel through the system. Over the 10 minutes of boiling, we collected 14 milliliters of condensed water. Although small, this showed the steam flow, condensation, and transfer were all possible. We also identified major issues such as weak seals, heat loss, and leakage, which became key drivers in our next iteration.
Our third prototype was a refined virtual model that represented how the full filtration system would work in a hospital setting. We estimated that with a 235 to 255 watt solar panel operating for 5 hours in ideal conditions, the system could boil roughly 10 liters of reusable water per day. The updated filtration system, featuring a more sophisticated shape, improved tubing, and cooling system, addressed the limitations of the second prototype. The final model meets all of our design specifications more effectively. It's simpler, cleaner, more durable, and better suited for real-world use.
This being said, given our budget, the Sunblock for drugs has its challenges as we designed a prototype that was focused on a specific component rather than being comprehensive. In addition, the water that is produced from the drainage system is specifically used for water recirculation in toilet systems, as it does not undergo a purification test to pass as drinking water.
Even with a few limitations, our team was able to move from simple brainstorming to real testing and a design that actually worked. Each prototype showed us what wasn't working, which helped us refine the system into something more practical for healthcare facilities. With more development like real solar testing and better fabrication, this design could seriously reduce pharmaceutical pollution and support a more sustainable water cycle in these facilities. Thank you for watching.